The Navy is working hard to advance an emerging ghost fleet concept wherein multiple surface, air and undersea drones operate in a synchronized fashion to conduct a wide range of combat missions without placing sailors and marines at risk. We want to have multiple systems teaming and working together, surface, air and undersea, Captain John Rucker, Program Manager, Unmanned Maritime Systems, POLCS, said at the recent Surface Navy Association. Rucker explained that the Pentagon and Navy are advancing this drone fleet concept to help to search and destroy mines, swarm and attack enemies, deliver supplies and conduct intelligence, reconnaissance and surveillance missions, among other things. Swarms of small aerial drones, engineered with advanced computer algorithms, could coordinate with surface and undersea vehicles as part of an integrated mission, he explained. As communications and networking technologies continue to evolve rapidly, drones will increasingly be able to function in a cross-domain capacity, meaning across air, sea, land and undersea operations. Aerial swarms, for instance, could detect an enemy surface vessel and relay information to unmanned surface vessels or undersea drones to investigate or even attack. All of this could operate in a combat circumstance while needing little or no human intervention. Rucker explained that the Navy, and its Office of Naval Research, ONR, has been working closely with the Pentagon's once secret Strategic Capabilities Office, or SCO, in an effort to fast-track this kind of technology into operational service. The Strategic Capabilities Office is a special DoD-level effort to harness, leverage and integrate near-term emerging technology for faster delivery to combatant commanders at war. Much of this involves merging new platforms, weapons and technologies with existing systems in a manner that both improves capability while circumventing a lengthy and often bureaucratic formal acquisition process, Dr. William Roper, SCO Director, told a small group of reporters last year. The Office of Naval Research, ONR, has demonstrated technological advances in autonomy with groups of swarming unmanned surface vessels, USV, designed to detect enemy ships, perform surveillance missions or even launch attacks, service officials said. Algorithms governing autonomous maritime navigation have progressed to the point where USVs can more effectively perceive and respond to their surrounding environment while in transit. Robert Britzler, Program Manager, Sea Platforms and Weapons. During a recent swarm boat demonstration in the lower Chesapeake Bay, ONR developed boats achieved a key milestone in the area of autonomous control. Unlike purely remote-controlled boats, these boats are able to perceive their environment and plan their routes without human intervention. The role of the human is supervisory control, Britzler said. A human at a control station, using a low-bandwidth connection, can perform command and control functions without needing to actually drive the vessels. The demonstration used 4 USVs, working in tandem to perform a range of potential maritime combat operations. All 4 of the boats were able to see and sense a common picture for route planning, hazard avoidance and collision prevention, developers said. We are using a first-of-its-kind sophisticated perception engine which senses the presence of other vessels using a combination of sensors, radar, cameras and processing algorithms, Britzler explained. The ONR demonstration used 7 to 11 meter boats already in the Navy inventory as manned boats, and configured them with an autonomy kit enabling a range of unmanned mission possibilities. The kits, called Control Architecture for Robotic Agent Command and Sensing, or CARACAS, are engineered to provide USVs with an ability to handle dynamic operational situations. This can include the execution of search patterns, harbor defenses, surveillance or even swarm boat attacks. Other possibilities among a wide range of uses include using autonomous USVs for supply and weapons transport, counterman operations, electronic warfare and amphibious operations. The USVs are programmed with sensors linked to an established database of known threats such as enemy boats. They are also linked to one another with an ability to detect, track and trail unknown boats, Britzler said. ONR is working closely with the Pentagon's once secret Strategic Capabilities Office, or SCO, in an effort to fast-track this technology into operational service. The Strategic Capabilities Office is a special DoD-level effort to harness, leverage and integrate near-term emerging technology for faster delivery to combatant commanders at war. Much of this involves merging new platforms, weapons and technologies with existing systems in a manner that both improves capability while circumventing a lengthy and often bureaucratic formal acquisition process. Dr. William Roper, SCO Director, told a small group of reporters. A key advantage of using remotely controlled drone ships is that, quite naturally, they can save sailors and marines from being exposed to enemy fire during an attack operation. In fact, Roper maintained that USV autonomy brings the potential of substantially advancing amphibious warfare tactics. This can greatly help expeditionary logistics for a ship that is standing off from the shore. Instead of having to use an amphib manned by a lot of people, you have an unmanned supply boat, Roper explained. Fast-moving USVs could indeed lower risk and increase efficiency for a large number of missions, to include intelligence, surveillance and reconnaissance, ISR, counterman operations, search and rescue, electronic warfare, supply and weapons transport and amphibious assaults. Higher-tech enemy sensors and longer-range surface and land-fired weapons have drastically increased the vulnerability of approaching amphibious assault operations, making them more susceptible to enemy fire. As a result, the Navy and Marines have been evolving amphibious tactics to include more disaggregated approaches designed to spread out an approaching force, making it more difficult for enemy weapons to attack an advancing assault. For example, the Iwo Jima attack in the Pacific during an historic amphibious assault, involved a group of Marines approaching enemy shores in close proximity to one another. Weapons, Marines, equipment and attacking infantry all came ashore in rapid succession. Modern threats are changing amphibious tactics to succeed against higher-tech, more lethal enemy weapons. Instead of having to land as a single unit, they can now break out. There is safety in numbers and they can redistribute, Roper explained. When it comes to offensive surface operations, unmanned boats could form a swarming of small attack craft designed to overwhelm and destroy enemy ships with gunfire, explosives or even small missiles. Roper explained that this strategic and tactical trajectory is greatly enhanced by the possible use of USVs. The Navy's current inventory includes ship-to-shore amphibious craft called landing craft air cushions, LCACs, and landing craft utility vehicles, LCUs, these platforms, now being upgraded by newer transport boats able to move faster and carry more payload, such as Abrams tanks, are manned and therefore involve the use of a crew. LCACs require a crew of 13, and LCACs use a crew of 5. New high-tech LCAC replacements, called ship-to-shore connectors, are already being developed and delivered to the Navy by Textron. The Navy and ONR are already immersed in the development of a variety of USVs, including a mine-detecting unmanned influence sweep system, or UIS, for the littoral combat ship. The UIS is carried by a Textron-developed Common Unmanned Surface Vehicle, or CUSV. The CUSV, in development since before 2009, can travel for more than 20 hours carrying up to 4,000 pounds at speeds of up to 20 knots, Textron information states. Also, it is engineered to withstand waves up to 20 feet. The UIS is engineered to find and detonate undersea mines in order to save sailors and manned vessels from a potentially deadly explosion. The Navy's UISS will be towed behind the unmanned vehicle and will emit sounds and magnetic signatures that mimic a ship, setting off nearby mines that listen for passing ships, according to a report from the U.S. Naval Institute. The Navy is also advancing its recently christened Defense Advanced Research Project Agency, or DARPA, inspired submarine hunting unmanned ship called Sea Hunter. The ship is built to travel up to 10,000 miles while using sonar and other sensors to locate enemy submarines. A high-frequency sonar will send acoustic pings into the ocean before analyzing the return signal to determine the shape, size, speed and characteristics of any undersea enemy activity. The 135-ton ship is engineered to withstand rough seas up to sea state 5, or waves up to 6.5 feet. The effort began in 2010 as an anti-submarine ship called ASW Continuous Trail Unmanned Vessel, or ACTUV. The Sea Hunter can be controlled by a human teleoperator able to maneuver the ship with a joystick. Also, it is possible the Sea Hunter could be armed with lethal weapons in the future, a scenario which current Pentagon doctrine says much hinge upon a human decision-maker in the role of command and control. The Sea Hunter can be controlled by a human teleoperator able to maneuver the ship with a joystick. However, the progress of the platform's technology, and the rapid advancements of algorithms enabling greater levels of autonomy, have inspired the Navy to begin thinking about additional missions for a drone that was initially conceived as a sub-hunting vessel. Right now, the sky is the limit. Do command and control and go investigate, Rucker added. If the Sea Hunter is both more autonomous and armed with lethal weapons in the future, it will be engineered to align with current Pentagon doctrine, which says any use of lethal force must hinge upon a human decision-maker in the role of command and control. The Pentagon's research arm is also extending testing of its sub-hunting drone able to travel autonomously for up to 90 days using sensors and sonar technology to search for enemy submarines and other airborne and undersea threats such as mines. Meanwhile, the Navy is also developing refueling unmanned surface vehicles that are launched and recovered from a host ship. A refueling and data transfer system that is remote from the host ship and proximate to the USV operating area will allow a substantially greater fraction of a Navy USV's endurance to be spent on performing the mission rather than on non-mission activities associated with refueling, including transiting to and from the host ship and being deployed and recovered on the host ship. This effort, asking industry to design, build, test and demonstrate a prototype USV to be called Off-Board Refueling and Data Transfer System, or ORADS. It will be designed to be more rugged and survivable than existing USVs and travel at longer ranges to extend mission possibilities. The ORADS design must improve on previous designs by providing a more robust system that enhances system usability in higher sea states, reliability, and maintainability for implementation in Navy operations, a Navy Broad Area announcement states. This initiative represents a portion of the execution or operational manifestation of a 2007 service roadmap called the Navy Unmanned Surface Vehicle Master Plan, which calls for the eventual combat deployment of a broad range of USVs to include ships for counterman missions, surface warfare, anti-submarine warfare, special operations support and electronic warfare, among other things. Plans for USVs include a small X-class of boats, a 7-meter harbor class, a snorkeler class and an 11-meter fleet class boat, the master plan states. The currently sought-after ORADS refueling USV is slated to be a larger fleet class USV. It is approximately 38.5 feet in length, 10.5 feet beam and full load displacement 21,400 pounds. It can carry between 400 and 650 gallons of diesel fuel marine, DFM, and uses fuel at a rate between 25 and 40 gallons per hour, Navy documents describe. The refueling port of the USV is located on the starboard side of the craft, above the waterline, about midship. There will be up to 2 terabytes of data to be offloaded from the USV, per refueling iteration, the documents add.